Thank you. Who can define an equilibrium reaction?
Me.
Okay, so define an equilibrium reaction and let's go. We are solving questions.
Equilibrium reaction is a reversible reaction in which the rate of forward reaction is equal to the rate of backward reaction.
Oh, okay. God bless you. God bless you. God bless you. So now B, the following chemical reaction occurred at 120 degrees Celsius in 1.0 dm cube container. The following chemical reaction occurred in 120 degrees Celsius in 1.0 dm cube container. Now there's a reaction you are given. CO2 in gas, CO2 in gas plus H2 in gas, H2 in gas plus H2O in gas. Now, what type of equilibrium reaction is this? Which type of equilibrium reaction is this? Yeah.
Homogeneous.
Homogeneous. So you are saying that the following chemical reaction occurred in 120 at 120 degrees Celsius in 1.0 dm cube container. Now the quantities of the species determined at equilibrium were as follows. So these are the quantities they give us. CO2. So the CO2 is equal to, these are the quantities we're given. CO2 is equal to, we are given the masses, grams. We are given H2 to be equal to H2 to be equal to 0.003 grams, and we're given CO to be equal to 0.056, and we're given H2O to be equal to 0.0018 grams. Now the question is saying that calculate the Kc for the reaction. Calculate Kc for the reaction. Kc for the reaction. Now B, you are saying that B, what is the effect on the Kc? So let me just write it. What is the effect? What's the effect on Kc if the volume is halved? If the volume is halved at the same temperature. And you've been given the molar masses, the molar mass of H2, to be equal to 2. You've been given CO2 to be 44. You've been given CO to be 28. And you've been given H2O to be equal to 18. So they said we should find for Kc of the reaction. Who can tell me how we go about this one? Who can tell me how we should go about this one? Who can tell me?
You find your concentration first.
Yes, so we first have to find their concentrations and find their concentrations. We can find concentration using this formula. C is equal to mass all over molar mass times volume. So we are giving their masses, so we have to find for the concentration of this of CO2, H2O, CO, and H2O. Do you agree? So we first have to find for concentration of CO2, the concentration of into bracket CO2. That will be equal to the mass of CO2 0.022 grams all over 1 dm cube, 1.0 dm cube. That's what we are given. That's the volume times the molar mass. What is the molar mass? The molar mass of CO2 is 44.
44.
So what is it? Use your calculator. Punch it on the calculator. What are you getting? Now we come and find for that of H2. H2 will come and get 0.022 all over one of this. H2 is 2. So that is it. H2 is 2. Then we come and do that. So you write the distance. You come and do that for CO. CO2 will be equal to 0.056 all over 1 times what is it 28. Then you can get that one of the water, that of the water. So we can get that will be one times 18. So please let's write it. The first one, what do you get?
5 times 10 raised to the power negative 4 mole per dm cube.
Mole per dm cube. Negative 4. Or we can just write them in molar. Big M. Then this one is what?
1.6 times 10 raised to the power negative 3.
So 1.6 times 10 negative 3. What about this one?
2 times 10 raised to the power negative.
What? 2 times 10?
2 times 10 raised to the power negative 3.
And H2O will be
1.0 times 10 raised to the power negative 3. Or 1 times 10 raised to the power negative.
So now we have all the concentrations. So now we can use our Kc formula. So looking at the reaction, the Kc formula will be equal to CO H2O all over So we are now we have the concentration. So let's put them in it and give me the answer. What are you getting?
5/2, which is equal to
The answer will be what?
5/2 or 2.
Okay. So that will be 2.5. Case will be 2.9. The M's and the more per DMs will cancel, so you get 2.5. So that is it, Casey. Now we have some other set of questions that one I have to get time and take you through how it works. This one really have to do with. We have a format we use to solve them. The ICE formula, the initial, the change, and the equilibrium formats. That I have to take my time and teach it. So we do that one the next time we meet. I'm going to spend time to do all those things. I mean, next time we meet, we're finishing with equilibrium. So take notes. I'm meeting God willing tomorrow to do commerce or physics, any of them.
Yes, sir.
Ella, is it Daniela?
Yes, it's me.
Oh, okay. I've missed you. Okay.
So you know I said the last one. What is the effect of
Okay. When there's a decrease in volume, it doesn't affect it. It won't affect it.
Okay, sir.
It has no effect on the value of Casey. Okay. Have a wonderful day. Solve more questions. But there are some set of questions I want to take my time and teach you how it works. That one you have to understand. So you have to know whether the reaction will shift to this side or will shift to this side. And based on all those things, it will determine how you work it. So I have to take my time to do it.
Yes, sir.
Okay.
Thank you.
Have a wonderful day. I love you all. Yeah.
We love you too.
Bye.
Bye.